Hello guys, in this lesson, Mrs. Maitan is going to teach you elements, isotopes, and ions. You know more about atoms now. Electrons are outside, protons and neutrons are inside. Now it's time to get to know how elements differ from one another. So the first idea, what matter is made up of, came from Greek philosopher Empedocles after Dalton. After Democritus. Democritus thought that all matter was made out of same atoms. But this philosopher, he said, no, it's not. It's all matter is made up of four things: air, earth, fire, and water. Although this is not correct, this idea paved the way for several future scientific investigations. So, in our lesson, we are going to explore elements. And when we are exploring elements, we're going to examine the properties of an element, describe the isotopes of an element, and explain how ions form. So the first day, we will learn more about properties of an element, masses of atom, and atomic number. And then the next day, we're going to learn about isotopes, and the next day, we're going to learn about ions. So you can pause the video here now, and you can take down the vocabulary to know, the words to know in your guided notes. You will not see all of these in your guided notes, so you can just read and fill out the blanks, whichever the words are belonging to. Periodic table. So this is the periodic table that you may use all the time. You can come back and refer to find out the elements, the atomic numbers. So periodic table is first organized by Henry Moseley, the scientist. He organized this by atomic numbers, increasing atomic numbers from left to right. So hydrogen is 1, 2. As you can see, the top number is atomic number 3, 4, 5, 6, 7, 8, 9. Also, he organized from top to bottom by their physical and chemical properties. We will learn more about periodic table in the next lesson. So let's learn about more about elements. So an element is a pure substance, which means it's made of only one type of atom. It cannot be broken down into simpler form, and it makes up all matter in the universe. So this is a picture of gold. So when you break this down all the way down to the atom size, you'll still see the gold. You'll still see the gold's properties in that little piece too. So this gold is all made out of same type of atoms, same type of gold atoms. When it comes to symbols of elements, so Ti, Hg, so these are representing the elements. Okay, so mercury, the symbol of the mercury is Hg, and then the titanium's symbol is Ti. Carbon and iron is missing. I want you to figure this out using the periodic table. You can Google it, or you can use the one that I provided to you in this assignment. So these symbols, as you can see, capitalized. The first letter is capital, and then the next one is not capital. So you can see two or more letters, or one letter sometimes, okay? That's all you need to know about for now. Protons in an element. So elements are identified by their atomic number. Atomic number is the same as proton number. So this is important for you. And because every time you're given proton number, you're going to think about atomic number. Okay? So here, helium has 2 protons. That means the atomic number of helium is 2. Here, the calcium has 20 protons. The atomic number is 20. Here, the platinum has 78 protons. So that means atomic number is 78. So go ahead and fill out your notes accordingly. Electrons in an element. So electrons occupy the electron cloud, as you know, the latest modern atomic model by Schrödinger. So electrons are in the electron cloud. Each electron occupies an energy state. As you can see, there's like 6 energy state here, energy levels here. Electrons farther from the nucleus, so this one, for example, has a higher energy state. Okay, the electron cloud is divided into energy levels. As you can see, there's like 6 energy levels here. 1, 2, 3, 4, 5, 6. Each energy level can hold a certain number of electrons. Now, this is just a part of it, but you're going to learn more in the future. The first energy level can have 2, maximum 2. The second energy level can have maximum 8. And the third one, maximum 18, 18, and then 36, and go on. Okay? So the thing that you need to know in this slide is the first energy level can have maximum 2, and the second one can have maximum 8, and the third one can have maximum 18. So the outermost in the outermost level, for example, this one is called valence electrons. The electrons are in the outermost is called valence electrons, and they are having the highest energy, the higher energy than other electrons. The periodic table notation. So as you can see, this is a big white card. Is actually representing notation. Okay, what I call ID card. So 1 is representing the atomic number. Okay, it tells the number of proton in an atom of the element. Atomic number is used to identify an element. Again, atomic number. Periodic table is arranged by the atomic number, as I told you before. In an electrically neutral atom, the proton number is equal to electron number, and you also observed this in the PhET simulation when you were building an atom in the last lesson, remember. When the proton numbers are equal to electron numbers, like 3 proton, 3 electron, cancel each other and makes the atom neutral, right? So that symbol, H is the symbol, as I told you, okay? That is called symbol abbreviation for the name of the element. As you can see, this one is atomic number, and this one is the atomic weight. This one is the symbol. These are the different type of element notation. Don't get confused if you see these. So if you see a decimal number, that's the atomic weight for sure. Okay, if there's a decimal number, that's the atomic weight. Okay, so this is a 2 different version of the same type of element notation. Okay, sometimes people put on the top, sometimes put on the bottom. Well, the only thing that you need to know, if there's 1 decimal number, that's the atomic weight. Okay, and the other number is the atomic number. These 2 numbers are important because this is going to tell you everything about the element. This is the second type, so Na, the sodium. So mass number is 23. So see, there's no decimal number here. If there's no decimal number, the number on the top is the mass number, is the atomic weight. Well, atomic weight and the mass number is the same thing, okay? So that's the mass of the sodium. That's the mass of the neon. That's the mass of the neon. So sometimes on the bottom, sometimes on the top. Don't get confused, okay? All right. By the way, I should say you guys have to start writing everything down on this slide in the page that comes after this topic. After electrons and element topic in your notes, you should start writing everything about these slides. Okay. So let's continue. And this is another one that you guys have to write down everything. Mass number. So mass number is telling you the total number of proton and neutrons, okay? So this yellow highlighted is the basic formula to find the atomic mass. If it's not given to you, you're given proton and neutron, then you're going to add them to find the mass, okay? For example, let's find these out. In your guided notes, I need you to write these down too. Figure the masses of each element too. So carbon has 6 plus 6, 6 proton, 6 neutron. So you're going to add them up, which makes 12. That's the atomic weight or the mass number. Same thing, okay? That's the mass. Just say mass. Fluoride is 9 proton and 10 neutron. Add them up, that makes 19. So that's the atomic mass, okay? How about the calcium? 20 protons and 20 neutrons. That makes what? 40, right? So that's the atomic mass. So easy. Given the element notation, find the atomic mass and atomic proton numbers. So we'll get to do this in the class. So I'm passing it now for now. All right, so in your guided notes, again, there's a chart, okay? So you can use the periodic table in the beginning or the one that I attached to you. So you're going to figure out these blanks. How? So aluminum. Let's start from the aluminum. Hold on, I got to pull up my periodic table too. All right, folks, I put up my periodic table. You can do so. Let's get to do this. Aluminum. So the only thing given is neutron number of aluminum. So in the periodic table, aluminum is going to be in the third row on the right side of the periodic table. You should see the third row, the first element on the third row on the right side. It says Al, so I can read the atomic number. So the first thing that you have to figure out is atomic number is 13. Mass number. So how can you find out the mass number? So before doing the mass number, you can figure out the proton number. So remember, atomic number and proton numbers, they are the same thing, right? 13. And all the elements on the periodic table is neutral. That means electron number and the proton number is the same too. Now the only thing is left, mass number, and so easy to do. Remember, mass number is equal to proton numbers and neutron numbers, adding them together, right? So 13 plus 14 makes 27. The second row is, now we know the 25, proton number is 25. We know that atomic number and the proton number is the same, which is also electrons are the same number too. These all three is the same. Now, what is the mass number? 25 plus 30, right? Neutron number plus proton number, or neutron number plus atomic number. But you cannot add electron number and neutron number because electron number may change for some of the elements which are charges. So I'm not saying that. Anyway, so 55 is the atomic mass or the mass number. What element is that? So since we know the atomic number, we can figure this out on the periodic table. On your periodic table, you gotta keep counting until 25 from left to right, from top to bottom. Left to right, top to bottom, start counting 25, okay? So you're gonna find magnesium. I'm sorry, manganese, not magnesium, manganese. It's Mn. This is the symbol. So for the rest of the two, I'm leaving it to you, okay? Hopefully, you're gonna figure this out by yourself.